Welcome to Ask and Learn.
We want to find the absolute minimum and absolute maximum values of the function f of x equal to x cubed minus 3x squared minus 12x plus 1 on the interval -2, 3, which is a closed interval. So the first thing we got to notice is that f attains those extreme values, that is, its absolute minimum and its absolute maximum values on this interval because the interval is closed and the function is continuous because it's a polynomial function. So we know that those extreme value exists, but besides that, we know that those extreme values are images of either the endpoints of the interval or critical numbers of the function. So we got to start by calculating the critical numbers of the function. For that, we need the first derivative, and that is equal to 6x squared minus 6x minus 12. And we see that this derivative exists for every value x in the interval -2, 3. And for that reason, the only critical numbers f can have are those values of x for which the derivative is equal to 0. So and then we gotta start by solving the equation f derivative equals 0. And that's the same thing as 6x squared minus 6x minus 12 equals 0 because the derivative had this expression here. And that's the same as 6 times x squared minus x minus 2 equals 0. And because 6 is a non-null number, we can say this is the same as x squared minus x minus 2 equals 0. And we can factor out this polynomial as x minus 2 times x plus 1, and that equals 0. And this product is 0 if either of the factor is 0, so x is 2 or x is -1. And these two values in this case are both in the interval -2, 3, so they both has to be considered. Then the two critical numbers of f in the interval -2, 3 are 2 and -1. So we gotta find the images of these two critical numbers and the images of the endpoints of the interval. F at, let's say, -2 is equal to 2 times -2 cubed minus 3 times -2 squared minus 12 times -2 plus 1. And if we calculate all this, we get -3. That's the image of the left endpoint -2. Now the image of the right endpoint 3 is 2 times 3 cubed minus 3 times 3 squared minus 12 times 3 plus 1, and that gives us -8. And now we evaluate at the critical numbers. So f at 2 is 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 1, and that is -19. And finally, f at the other critical number, -1, is 2 times negative 1 cubed minus 3 times negative 1 square minus 12 times negative 1 plus 1, and that gives us 8. So the largest value of these 4 is 8, so it's the absolute maximum of f over the interval negative 2, 3, and the smallest of the values is negative 19. So this is negative 19 is the absolute minimum of the function over the interval. So we get that answer. Then f has an absolute minimum value negative 19, which occurs at 2, which is one of the critical numbers, at the critical number x equal 2, and f has an absolute maximum value we said 8, and that value occurs at negative 1, which in fact is the other critical number, at the critical number x equal negative 1. So this is an example where the two extreme values of the function happen or occur at the critical numbers inside a closed interval. So this is the final answer, and then wrapping all we did here, first thing we notice that the extreme values of the function exist because the function is continuous and defined on a closed interval, and we know those extreme values are images of either the endpoints of the interval or critical numbers of the function. We find the derivative, and because that derivative exists at every point or number in the closed interval, so the only critical numbers of the functions are those values of x for which the derivative is 0. We solve that equation, derivative of f equals 0. We stick with the solutions that are inside the closed interval. In this case, both of them are. So we evaluate the function at the two critical numbers we found and the endpoints, and the largest value of these 4 values is the absolute maximum of the function over the interval, and the smallest of the values is the absolute minimum value of the function on the interval. So this is the final answer to this problem.